In this video, we have to talk about a few things, particularly about the qualities or the types of variables and data that you're going to be dealing with. And I will use those terms interchangeably throughout this part of the video. Data, we're talking about the information that you've gathered. Right, so you've collected up information, but that's usually based on a variable. So by variable, we're talking about an attribute of the members of the population. And this tends to differ from one member of the population to the next. So, let's say, for example, height. If we're talking about the height of people, population of people, height will be different. It will vary from one to the other. And then other types of variables, age, hair color, reading comprehension ability, reading speed, mathematical ability, and so on. So again, the variable is an attribute of the members of the population that tends to be different among the members themselves. Okay, now the first two things we have to mention are probably familiar to you. Variables or data tends to be either qualitative or quantitative. And you're probably familiar with those terms, but let's review them just in case. When we talk about qualitative, this is data that describes or categorizes, uses words. So if we were to take a look at the number of red cars in the parking lot, these cars are red, so this would be a qualitative, because that's the variable that we're looking at. It's a qualitative variable. Quantitative uses numbers. Okay, so if we wanted to know how much people weighed, how old people were, what they scored on the SATs, this would be quantitative. So again, quantitative uses numbers. Qualitative describes or categorizes and uses words. So when looking at it and trying to assess, is something qualitative or quantitative, you have to be careful. So let's say, for example, we were counting the red cars in the parking lot over the course of a month to come up with an average. Or as we'll discuss later on in this course, in about another week, the mean. And we say, okay, there's an average of 24.71 red cars in the parking lot each day. Okay, it is still qualitative because what we're looking at, the individual variable, is red. We're not looking at what has been done with the information, anything that's been moved around or manipulated. So if you're assessing whether it's qualitative or quantitative, you want to take a look at one instant. What's the variable itself that we're looking at? Now, when we're talking about quantitative, and this is the one we use numbers, right? So we have numbers with quantitative. There are also two types of quantitative that you need to be aware of. The first is continuous. Now, continuous can have any value between the highest value and its lowest value. So it had any value between its highest value and its lowest value. So if we were looking at people's height, well, a person's height, if we're talking about it as tall or short, well, that would be qualitative, wouldn't it? But if we're talking about the very specific measurement, the person is 5 foot 10 inches. Okay, now it's quantitative. Height measured in that particular aspect, like 5 foot 10, is continuous. Whatever the shortest person is, let's say it's 4 foot 11, and the tallest person is 6 foot 5, we could have any value between those. You could have someone who is 4 feet 10 inches, or no, 4'11" was the smallest, I apologize. Let's say it were 5 foot 1.37019 inches. So if you can do that with it, it's continuous. Where discrete can have some, but not all of the values between the highest and the lowest. So, for example, if you were to count the number of chairs where you live, in the house or apartment where you live, there's a certain number of them. You're not going to have 2.79 chairs. You might have 3 chairs, 2 chairs, 1 chair. That would be discrete. It can have some, but not all of the values between the lowest and the highest, where continuous can have any of the values between its lowest and its highest. Think of it along the lines, too, of when you go shopping. When they talk about things like less than, or fewer. Those are mathematical terms. When you're standing in line and the cashier's sign above the cashier says 10 items or, well, it should say 10 items or fewer, because those are integer values. You're not buying 0.41 of an item. When they say 10 items or less, that's actually grammatically incorrect. It would offend your ears if I was to add a cup of coffee here, and I would say when I started recording this video, and now I have this much coffee in it, I have fewer coffee. No, you would say less coffee, because less is associated with continuous, fewer with discrete. And that's just like an English use in everyday language for continuous versus discrete. Now we have to talk about levels of measurement. Now, the levels of measurement sort of describe the data and tell you the level of precision that you have within the data that you're dealing with. The first level is nominal. Nominal is for naming or categorizing only. So this places things in categories, but it doesn't measure its magnitude. It names. So we want to know if the person is tall or short. That categorizes them. What type of car people are driving. A Ford or a Toyota or a Chevy. It names and categorizes. That's it. And the order that you place them in makes no difference. So if you want to put Ford ahead of Toyota because it's alphabetical, okay. You want to do it reverse alphabetical, Toyota ahead of Ford, so what? It makes no difference. The order is unimportant in nominal. And with the variable itself, you can do no math. You can add up the Fords and add up it makes no difference. You look at the variable, you can do no math with this. So nominal is the least precise of the 4 levels of measurement. It's naming and categorizing only. There's no magnitude, there's no math, and the order is arbitrary. It's qualitative. And qualitative tends to use words, but it doesn't always. For example, social security numbers. Those are a nominal level of measurement. You can place them in whatever order you want, it makes no difference. You could also add up everybody in the class's social security number and divide by 21, and no one cares. It means nothing to anyone. So nominal, the least precise. The next level of measurement, which is slightly more precise, is ordinal. Now with ordinal, order matters, because ordinal is a ranking system. So things like first place, second place, third place, those would be ordinal in nature. But they're not equal distance. So for example, if we looked at birth order, that's an ordinal level of measurement. The oldest child is 4 years older than the next child. And the second child is 2 years older than the third. And the third child is 1 year older than the fourth. And the fourth child is 4 years older than the fifth. The order matters, but the distance between them are not equal. There's no math involved with ordinal. So you can add up first and second place scores in a race. It makes no difference. The order is really what matters, but the distance between the points are not equal. So if we were to say a Likert style scale, a scale of 1 to 10, 10 being the happiest, 1 being depressed, that would be an ordinal level of measurement. And if we were to ask that in the class, most people would say that they feel around a 7 if they're feeling okay. Now, if 4 people in the class say they feel about a 7, does that mean they feel the same? No, it doesn't. It just tells you that they assess this at around the same rank. And also the person who feels an 8 doesn't feel that much better than the 7 does to a 6. Is it equal spacing? No, it's not. So the precision with ordinal comes from putting things into an order. If you're writing a paper for one of your classes and you start using bullet points, okay, no, that's not ordinal then. If you start using numbers as we're doing here, 1, 2, 3, that's an ordinal ranking system at that point. Now for the levels of measurement, the next two, interval and ratio. In your textbooks and in a lot of stats textbooks, you'll see them use interval/ratio or I/R. If you're using IBM SPSS, the computer program, or if you're using Excel, they'll give you choices of levels of measurement. They'll say nominal, ordinal, or scale. When they say scale, they're referring to both interval and ratio. For all sorts of reasons, these two are the same. Let's take a look at the similarities, and then we'll talk about the difference, because the difference is really what's important in this class. In interval, the order matters, and order matters in ratio as well. In interval, the distances are equal between them. So the distance between 1 and 2 is the same as the distance between 2 and 3. In ratio, the distances are also equal. In interval, you can do math with these variables. And ratio, you can do math with these variables. In fact, mathematically, interval and ratio are identical. There are no differences between either one, which is why your computer programs and your textbooks all list them as scale or interval/ratio, because mathematically there is no difference. They're identical. But there is a difference between them, and we should be aware of it. The difference is, in interval, there is no true zero. And with ratio, there is true zero. So what does no true zero mean? Well, in interval, 0 does not necessarily mean the empty set. For example, you wake up in the morning, you turn on the news, and the meteorologist says it's 0 degrees outside. Does that mean there's no temperature? No, it means it's cold outside. Another example, if you go into a clothing store and you take a look at women's clothing size, there is a size called 0. Now, does that mean the woman that wears a size 0 has no size? No, it just means that she's small, possibly petite. But with ratio, true 0 does mean nothing. An example would be if you have a bank account and you have 0% interest, you have no interest. There is no interest there. That would be a ratio level of measure. So in determining which is which, ask yourself, does 0 mean nothing? If 0 means nothing, you're talking about ratio. If 0 means something other than nothing, we're talking about interval. And that's important as far as the interpretation of what you're looking at. So let's say we have the tallest person in the class and the shortest person in the class standing next to a desk. And we measure from the top of the desk to the top of the tallest person's head. And we find that the distance from the top of the desk to the top of his head is 3 feet. And then we take the shortest person and we find that the distance from the top of the desk to the top of her head is 1.5 feet. Could we then say that he is twice as tall as her? No, that wouldn't be accurate, because our 0 point is arbitrary. It's not a true 0. And the interpretation of that puts it into a gray zone. And that's some of the things that make statistics a little bit tricky sometimes. So you have to take a look as far as interpretation of data. And this is not a math stats class. This is an applied stats class. So understanding whether we're talking about interval or ratio, mathematically, makes no difference. For interpretation and understanding of what we're measuring, it makes a very big difference. So that's what we had to cover on this. aspects of data or variables. Are we talking about qualitative or quantitative? Continuous or discrete? And then the levels of measurement: nominal, ordinal, interval, and ratio. Nominal, the least precise; ratio, the most precise.